Hello, Algebra 2, Part 2. This is 831, which is solving equations that are quadratic in form. So this is the first day of it. We'll get some more practice tomorrow. So the whole point of this is to solve an equation that is quadratic in form, and by that we mean it looks quadratic. So you know, a typical quadratic equation is ax squared plus bx plus c equals 0. And the key there is that your greatest exponent is 2, and all of your exponents are going downhill. Well, so this we could say is a real quadratic, and then something that might be a quadratic in form could look like ax to the 4th plus bx squared plus c is 0. Okay, so here if we look at these exponents, we've got an exponent of 4 and an exponent of 2. Now you have an exponent on this x right here, you just can't see it. We could say that that exponent there is 1. Okay, and so what we have going on in the real quadratic is that our greatest exponent of 2 is double the next exponent of 1. Okay, and so something that's quadratic in form, you want to have a similar relationship. You want your greatest exponent to be double the next exponent. Okay, so this next example that we pulled up, this is a quadratic in form, and we could say here that our greatest exponent of 4 is double the next exponent of 2. Okay, and so what makes it a quadratic in form is that the greatest exponent is double the next exponent, and that's what you're looking for, that your greatest exponent is double the next exponent. Okay, real quadratic, your greatest exponent is 2, and then a quadratic in form, your greatest exponent can be anything as long as it's double the next exponent. Now, you have learned how to solve some quadratic equations, and so if we take a look at that, let's see, if you have something like, if we throw one up here, if you have something like x squared plus 5x plus 6 is 0, and you wanted to solve this, you would factor this with first and last, right? And you would get 1 and 1, and 2 and 3, and you would cross multiply, and 1 times 2 is 2, and 1 times 3 is 3, and then you would add those together and get 5, and then you would have x plus 2 times x plus 3 is 0, and then you would separate those, so you get x plus 2 equals 0, x plus 3 equals 0, and then you would solve those, and x is negative 2, and x is negative 3. So your two solutions you would get would be negative 2 and negative 3. So this is how you would solve a real quadratic. And we went over this at the end of Chapter 5, and then we did it again here in the beginning of Chapter 8. So let's say we take a similar problem, but it's a quadratic in form. So maybe we have something like x to the 4th plus 5x squared plus 6 is 0. So how would we go ahead and solve this? Well, we would start the same way. So we could go ahead and factor this with first and last, right? And we would get the same pairs of numbers. And so we would go to put them in parentheses, right? We would have our two sets of parentheses, and the whole thing would be set equal to 0. So now here's where the one difference comes in. When we go to put them in parentheses, the variable and the exponent that we're going to have in our parentheses is going to be the same as the middle term there. Okay, so in the real quadratic, we had x plus 2 and x plus 3. Here, we'll have x squared plus 2 and x squared plus 3 equals 0. Okay? So then, we would take each one of those and separate and solve. So I would minus 2, x squared is negative 2, right? And so then I would take the square root of both sides. Well, can't do the square root of negative 2, so we can pull the I out. That would be I root 2, and we know we have two options, positive or negative, right? And then we would do the same thing on the other side. Minus 3, x squared is negative 3, so we take the square root of both sides, and x is plus or minus I root 3. Okay, so the two possibilities that you would, or rather, this ends up being 4 possibilities, right? This ends up being 4 possibilities because you've got these plus or minuses that makes each one worth 2 answers. Okay, so 2 ways to do it for similar problems, just some small differences as we go through this. So we'll do some more examples like that today. Now, the important thing to remember before you solve these things that are quadratic in form is you want to check that it's written in standard form. You want to make sure that you have everything on one side of the equal sign and then it's set equal to 0. And then you want to make sure your exponents are going downhill and that your greatest exponent is double the next exponent, right? So here, 4 is double 2, okay? So now we can go ahead and try some more of the classwork problems. Let's see. So for this classwork, number 1, I have z to the 4th minus 5z squared plus 4 is 0. So I'll factor this with first and last. In the middle, I have negative 5, so I have 1 and 1. 2 factors of 4. Let's do negative 4 and negative 1. Cross multiply. Get a negative 1. We get a negative 4. We can add those up. That gives us negative 5. So our 2 sets of parentheses, and we're going to take the variable and exponent from the middle here. We'll have z squared minus 4 times z squared minus 1, and the whole thing is set equal to 0. So we separate these. So you get z squared minus 4 is 0, z squared minus 1 is 0. Okay? Now these can be factored. Well, actually, these we could solve by taking square roots, right? So you could add 4, z squared is 4, and then if you take the square root of both sides, z is plus or minus 2, okay? And the reason why this one worked out nicely like that is because 4 is a perfect square. And we can do the same thing on the other side because 1 is also a perfect square. So add 1, z squared is 1. Take the square root of both sides, and z is plus or minus 1, right? So you'll have 4 solutions. You have positive or negative 2 and positive or negative 1. All right, let's go on to number 2. So for number 2, we have x to the 4th minus 20x squared plus 64 is 0. So we'll factor with first and last. So let's do 1 and 1 and 2 factors of 64. Excuse me. Let's try negative 4 and negative 16. So cross multiply, we get negative 16 and negative 4. Add those up, we get negative 20. Okay, so again in our parentheses, we'll take our middle variable and exponent. So we'll have x squared minus 4 times x squared minus 16 equals 0. And then we separate both of these. Whoops, that should be x squared minus 16 is 0. Separate both of those, and set them equal to 0, and then we can solve these. Now 4 and 16 are both perfect squares, so we could solve these by taking square roots. So add 4, x squared is 4. Take the square root of both sides, and x is plus or minus 2, right? And we do the same thing on the other side. Add 16, x squared is 16. Take the square root of both sides, and x is plus or minus 4. So you have 4 solutions again, plus or minus 2 and plus or minus 4. So let's go on to number 7. Alright, so for number 7, we have x minus x to the 1/2 minus 20 is 0. Alright, so this looks a little weird because we don't have an exponent here, and we have an exponent of 1/2. Even though you don't have an exponent on that first term, there's one hiding there you just can't see. That's going to be 1. And if you think about it, 1 is double 1/2, right? Your greatest exponent in this whole thing is 1, and that's double 1/2. So we can solve this as a quadratic in form. So we'll go ahead and factor it with first and last. Right, so first is the coefficient in front of this x, which is 1. Our last is negative 20. And what we have in the middle, there's a negative 1 in front of that x to the 1/2. Alright, so we'll have 1 and 1. 2 factors of negative 20. Let's have a negative 5, positive 4. Cross multiply. So 1 times 4 is 4. 1 times negative 5 is negative 5. Add those up, and we get a negative 1. Now, in our parentheses, we take our middle variable and exponent. So we'll have x to the 1/2 minus 5 times x to the 1/2 plus 4 equals 0. Now, when you have something raised to the 1/2, that's the same thing as the square root. So we can rewrite that as the square root of x minus 5 is 0, right? And then the other one is going to be the square root of x plus 4 is 0. So we can go ahead and solve both of these. So add 5. So I have the square root of x is 5. Let's square both sides, and I'm going to get x is 25. Let's do the same thing over here. Minus 4. The square root of x is negative 4. Well, you know that you can't take a square root and get a negative number like that. So this is going to end up giving you no solution. And so for this particular problem, you only have one answer, which is x equals 25. Alright, so going on to number 8, we have a similar type of problem. So for number 8, you have w minus 20w to the 1/2 minus 8 is 0. Okay, so again, you've got this exponent of 1 that's hiding on your first w, and that's double your middle exponent of 1/2. Okay, so factoring this with first and last, first is 1, last is negative 8, and then in the middle we have 20. So I'll have 1 and 1, 2 factors of negative 8. Let's see. Well, if we did 8, if we were to do 4 and 2, and 8 and 1, I don't think this is going to factor. No, I don't. And I actually wonder if this is a typo. I think it should be switched up where it should be w to the 1 minus 8w to the 1/2 minus 20 is 0. Last. Yeah, because if you did that, then you would have, let's see, first is 1, last is negative 20, and then in the middle you have negative 8. If you do that, you could do negative 10 and 2, right? And that gives you a 2 that gives you a negative 10. Add that up. Negative 10 plus 2 is negative 8. Yeah. And so then we would have, let's see, w to the 1/2 minus 10 times w to the 1/2 plus 2 is 0. So then we would get the square root of w minus 10 is 0, and the square root of w plus 2 is 0. So add 10, so root w is 10, and then you square both sides, and you would get w is 100, and then we would minus 2, and the square root of w is negative 2, and you can't take the square root of a negative, so then this one is no solution. So your answer is w equals 100. Okay, so yeah, there was a typo in this this particular problem. So the 8 and the 20, well, in the original, the 20 and the 8 should have been reversed. Okay, so let's go on to number 20. Let's see. Alright, for number 20, we have x minus 9x to the 1/2 plus 8 is 0. So factoring this with first and last, first is 1, last is 8, and then in the middle we have negative 9. So 1 and 1, and two factors of 8, let's do negative 8 and negative 1. Cross multiply, 1 times negative 1 is negative 1, 1 times negative 8 is negative 8. Add those up and we get negative 9. Okay, so now going into our parentheses, well, we can use this x to the 1/2 in the middle for our variable and our exponent. So we'll have x to the 1/2 minus 8 times x to the 1/2 minus 1 is 0. So I'm going to get, and this x to the 1/2, we'll rewrite that as the square root of x. So square root of x minus 8 is 0, and then the square root of x minus 1 is 0. Okay, so add 8, so root x is 8, and then if I square both sides, I'll get x is 64, and then add 1, and then the square root of x is 1, and I square both sides, and I get x is 1. So I get two solutions, 64 and 1, and I'm all done. Let's take a look at 21. So for 21, we have y to the 2/3 minus 5y to the 1/3 plus 4 is 0. So this looks a little different. We haven't seen any exponents yet, like 2/3 and 1/3, but we can still go ahead and do it because 2/3 is double 1/3, so it's still okay. So first is 1, last is 4, and then in the middle we have negative 5. So factors of 1, 1 and 1, factors of 4, let's have negative 4 and negative 1. We cross multiply, we'll get negative 1. 1 times negative 4 is negative 4. Add those up and we get negative 5. So in parentheses, we're going to take our variable and our exponent from the middle. So we'll have y to the 1/3 minus 4 times, and then we've got this 1 and negative 1 together. So that'll be 1y to the 1/3 minus 1 set equal to 0. And remember, if you have anything raised to the 1/3, that's the same thing as having a cube root. So we could say this is the cube root of y minus 4 equals 0, and then the cube root of y minus 1 is 0. So solving both of these, so I add 4, so I get the cube root of y is 4, and then I'm going to take both sides and I'm going to raise them to the 3rd power, so I'll get y is 64 over here, right? And then I'll do the same thing on the other side, so I get the cube root of y is a positive 1, and then take that and raise that to the 3rd power, and I get y is 1. So my two solutions here are 64 and 1, and we're all done. So that's it for our first day of 831. So I hope you know enough to try the accuracy problems, or try the homework, and then we'll do some more tomorrow.